Well, good evening, everyone. I'm Anthony Luscre, K8ZT, and we have Marty, who's still muted.
I thought I muted myself. Unmuted my. Oh, there we go. Okay, I'm Marty Woll and 6 Victor India.
Tonight's topic is Beginner's Guide to VHF UHF Week 2. If you missed Week 1, you can watch a recording of it on YouTube or on Vimeo. My contact information is in here, as is Marty's, and a link to the slideshow. We'll be putting up PDFs though that you can access. But if you want to get to the slideshow, tiny.cc/BG VHF, Beginners VHF. These are the topics we're going to be covering tonight, and we're going to bounce back and forth. The blue M's are Marty, the red A's are me, and we're going to talk about radios a little bit more this week. We covered antennas extensively last week, so let's just jump in. Marty's up first. Before we get started, Marty, I had a question. I got an email.
Right, yeah, go ahead.
There was a question about, we talked about CTCSS when we were setting up the talk to repeater last week, and we don't really have time to go into it a lot more. So what I did is I put together 5 resources that you can use. The first one goes into detail about the technology of CTCSS and DCS, talks about the pluses and minuses for using each. And then there's some general ones on information on using tones, stuff you need to know to set up VHF, UHF rig, including tones and some other things, how to program CTCS and offset on the Bofang UV5R, which is a very common radio, and information on setting up programming one of the base units, which would be the Yaesu FT991. These are all videos that you can watch for more information on CTCS, and hopefully they'll answer the questions you might have. So I'm going to turn it over to Marty now.
Great. Thanks for doing that, Anthony. Good evening, everybody. When you're first setting up a station and you're deciding what it is you want to get, the temptation is generally to start with a handheld. It's less expensive, and obviously it has the flexibility of being able to be used anywhere you are. But there are some drawbacks. So let's kind of talk about setting your station up, starting with a handheld. As you probably know, they are necessarily low power devices, both from an RF safety standpoint, because you're holding it next to your head, and also from a power capability standpoint, because they're powered by a battery that will run out when you run more power. The ergonomics on these I find a bit suboptimal. If you're under 40, maybe that's not a big issue for you, but I find the smaller they make the radios, the harder it is to see the little labels on the keys and so on, not to mention the small screen. So a little hard to grab the control sometimes, and the readout can be somewhat limited. And as we mentioned, they have limited battery capacity. Most of the radios come with a pretty good internal battery these days, but you do have to keep it charged up. And by the way, you should always have the ability to put a pack of alkaline cells where the rechargeable battery would normally go. Most of the handhelds, except the sub-miniature ones, have that capability. It's usually an added extra. You should make sure you get at least one, maybe a couple. Because if the AC is out and you don't have access to that, you can't recharge the thing. So having the ability to run off double A's or whatever it is good. An antenna is usually included in the handheld, but it's also pretty poor. It's got negative gain. They're not very efficient, but you can't have the thing a couple of feet long and still not get caught in doorways and hit people in the eye. So that's just the way it goes. Go ahead, next. Okay, so last week we talked about antennas, and one of the first things you can do is use an outside antenna with your handheld. You're not limited to the one that comes with it. So if you haven't already looked at that video where we talked about antennas you can buy and antennas you can build, sometimes for very little money, a few dollars, take a look at that and think about how you might employ an antenna that isn't directly mounted to the radio. Next. So we talked about low power being something of a disadvantage. You can get an amplifier that will boost the output. Typically, they'll take anywhere from 1 to 5 watts input, and they'll give you 25 to 30 watts out. That's getting on the order of what you'd get out of a mobile radio. Some of them even have a receiver preamps built in, although a preamp right at the radio is a little less useful than a preamp up at the antenna. And these amplifiers are generally simple to use. They have automatic switching. They detect when you're transmitting, and they'll switch the amplifier over. You don't need any external relays or anything like that. Here are a couple of examples showing, and you may find them monoband, such as the one on the right, or you may find them, maybe they'll cover more than one band, such as the one below. Next. Now, there are some issues with using an external amplifier. First, once you have an external amplifier, you are going to need an external power supply. Amplifiers don't come with their own batteries. They run off external power, whether it be a big deep cycle battery or an AC based power supply. And then you're going to need a cable to run between the amplifier and the radio. And of course, that's in addition to the cable that connects to the antenna. Sometimes those amplifiers can be as expensive as a mobile, or maybe even a little more. A typical new single band amplifier I've seen running around $230, and a dual band amplifier around $375. So just order of magnitude, that'll tell you what your investment is there. Now, again, you're putting out a 30-watt signal. People will hear you a lot better than they will with a 5 watts out of your handheld.
And these used to be a lot cheaper, Marty. The prices almost doubled over the last 10 years on these.
Yeah, that's nothing. Take a look at rotators.
Yes.
Those used to be really cheap, and now they're quite expensive. But keep an eye out. You can find good used deals from, if you find a reliable seller. I found some very good deals on small amplifiers, maybe for packing away in my wife's car, so that if she needs it and has not just the handheld, she could boost the output a little bit if she needs to. Then, of course, if you are interested in using any of what we call the weak signal modes, single sideband, CW, or digital, you'll need, an FM handheld will not cut it on those modes. However, most of these amplifiers, if you upgrade to another radio later that's also low power, can be used on those other modes. Most of them can do all modes, so that's a good thing. Next. Of course, for me, reading glasses when you're looking at small numbers on the buttons or small screen. But another very handy device is a speaker microphone. This typically plugs into the side of the handheld, and it does a couple of things. One, it has a little better speaker than the one built into the radio, just because of the amount of real estate available on the front panel of these radios. And also, it allows you to have the microphone close to you, even if you want to, say, hold your handheld up in the air. If you're kind of in a marginal area, you get a little additional coverage. As far as power, there are a couple of ways to go. A good AC supply almost any good AC supply will run a handheld. If you're going to run the amplifier, you're going to need more. We'll talk about that in a minute. Another possibility is a good deep cycle battery. The traditional deep cycle batteries are lead acid based, and often the valve regulated lead acid ones, such as gel cell or AGMs, are a much better choice than the typical sloshy electrolyte automotive batteries.
And you're going to need one
very popular. Go ahead, Anthony.
One other accessory also, Marty. You're going to need a way to connect your radio. Some radios let you connect the battery directly, but most of them don't. So you need to buy a battery pack replacement that has a DC input. Yeah,
very good. And in the earlier handhelds, and certainly including many of the ones I have, run off a pretty wide range of voltages. My old Kenwoods would run from anywhere from 5 to 16 volts. So I could put just about anything in there and they'd work okay. Some of the newer ones are limited to 6 or 7 volts, so you can't plug 12 volts in directly. As Anthony says, you'll need some sort of adapter. Back to the batteries. The battery on the right is a lithium iron phosphate battery. This one comes from Bioenno Power, and they've become very, very popular among amateurs, particularly those doing field work. They have a number of advantages. Real briefly, they have a pretty constant voltage across their discharge curve. They don't just decline over the use of the battery, and they can be deep discharged and then recharged thousands of times, as opposed to a few hundred times for the lead acid construction. And they're light. Compared to a comparable lead acid battery, they're about 1/3 the weight. The bad news is they're about 3 times the cost. But given how many times you can recharge them, if you can afford it, it's a good investment and you'll use it. I know some of the ones I have will probably outlive me. Next. All right, now, so you have a speaker mic, drive cable, you got the amplifier, you got all this stuff hanging off the edge. Will it work? Yeah, it'll probably work. Did you save money? Not necessarily. And I think there is a better way. So let's look at that better way. A mobile transceiver, although they typically are sold and described as mobile, those are very compatible with a base station type operation. They have a lot of convenience. First, they run inherently more power, typically anywhere from 25 to 50 watts. Most of them have several power levels, so you can bring the power down to what you need to communicate. They have bigger readouts, brighter readouts. The controls are easier to grab. They have a bigger speaker, better audio, and you don't have to pick up the whole radio. You only have to pick up a microphone on a cord. And because you're not grabbing the radio all the time, you're not accidentally pushing the wrong button and all of a sudden being off frequency or changing channel or whatever else may happen. They have backlighting that can be left on all the time, which again, in suboptimal viewing environments can be really handy, especially if you have to change frequencies from time to time. They typically have a cooling fan, heat sink, or some combination of those. Some have a removable control head. If you're operating from your car, this can be really nice. You don't need to have the whole radio sitting on a mount somewhere where it's going to go flying around if you get in a crash. You could tuck it in the back somewhere and have just the control head, which is small and light, mounted at a convenient place. They typically have a lot of memories, although handhelds have a lot of memories too these days. The multi-mode radios tend to have up to 1,000 memories. Some of the monoband radios, maybe 100 memories. They'll typically, as I mentioned, have several selectable power levels. And I'm going to give you a suggestion here. When you get a new radio and you start programming channels into it, repeaters and some simplex frequencies, and maybe your response groups, comm plan, whatever it may be. I usually program those for less than the maximum power level, a medium power. And a part of the reason is that you don't always need that high power, and it can drain your battery faster if you're running off a battery. Second, the more power you run, the more heat you're going to generate. And heat is kind of the enemy of most electronics. And even though these things have ways of moving the heat through fans and heat sinks and so on, if you heat it up less in the first place, you'll probably get better service out of the radio over the years. So I usually program mine for medium, and then if I need to, I could just hit a button and it goes up to high power. All right, here are a couple of sample mobile radios. It's absolutely not comprehensive, but Anthony has a nice list of radios later on. I know some folks prefer not to buy the Chinese knockoffs. Typically, those with the Yaesus and the Kenwoods and the Icoms, so many people have those. The experience is all documented. The manufacturers take pretty good care of those things, and the warranty is good. I've had to send radios that I've somehow gotten damaged through excessive field handling back to factory, and I've gotten very good service, and they came back working like new and no problems. So these are some of those that we in Los Angeles ACS and Aries use. And you see the one on the lower left has that removable faceplate I was referring to if you want to do something with a mobile type arrangement. All right, next. So these are some of those I showed. The TMV71A is a multi-band radio. TM281 is a single band 2-meter radio. Yaesu has a number of good radios. Unfortunately, these are all discontinued now. I've used the 7900 and the 8800 extensively. I got them years ago and they still work great. Again, you can sometimes find a good deal on the used radios if you can't necessarily afford a brand new one. ICOM, Alinco, Bridgecom. Bridgecom is known now for a 220 radio that's pretty robust. Those tend to be hard to find on the 220 megahertz band, just because it's not a ham band in most of the rest of the world, and so the manufacturers who make radios to be used all over the world don't bother putting it in. The TYT stuff is typically clone of the Yaesu radios. Next. Anthony, why don't you take this?
Well, across the top we have a variety of handhelds. In the middle we have a bunch of mobiles, and in the bottom we have a few of the bases that are currently available. The one on the far right might not be considered a base. That's the ICOM 705, which they claim is a mobile radio, or a portable radio, I should say. So when we're looking at buying radios, there's a number of different categories, and for today's purposes we're going to ignore the HF only radios, but we have the possibility of buying a VHF, UHF radio, either analog or digital, and I'll talk more about that a little bit later. We have the different form factors, HTs, mobiles, and base stations. And then the other option is a HF, VHF, UHF combo, sometimes called a shack in a box, something along the lines of the the Yaesu 991A, or that ICOM 705 that I showed a little earlier would be examples of that. They have both HF and VHF and UHF. There's a number of decisions when you're choosing a VHF, UHF radio, and one of the things is FM only versus a multi-mode. FM is going to be used for the bulk of the emergency communications, for local repeaters, for simplex, when you're walking around a hamfest or something like that. The multi-modes tend to be used more for contesting and for weak signal modes. We'll talk a little bit about those weak signal modes a little bit more later, but if you do have an FM only radio, you cannot do some of the multi-mode functions, like you cannot do FT8 with it, for example. Analog versus digital, and when I refer to digital here, I'm referring to digital FM voice. So things like DMR, D-Star, Fusion. We'll talk more about those later also. And then again, the form factor, HT, mobile, or base. Inexpensive brands or traditional brands. Single band versus a dual band radio. VHF and UHF only, or VHF, VHF combo. The primary bands you're interested in, the power output, and then finally, a really big new decision a lot of times is new versus used. Now, if you're considering a dual band radio, not all dual band radios are built equally. Some of them allow only one band to be used at a time. So when you're shopping for radios and comparing them, you might want to check out and see what the specifications are. Some allow you to simultaneously use two bands. They have dual receive capability. Typically on a dual receive radio, on a base station or mobile, they'll have two volume knobs. That's a tip-off that you're going to have dual receive. Some are limited only to using one band for VHF and one for UHF. Some of them do let you use both bands on VHF or both bands on UHF. They're the most flexibility. Some of the radios allow you to background monitor one frequency while using another band or frequency, and even some of the radios that have dual receive have the ability to have a background monitoring frequency that's not one of the ones being displayed. Some radios allow crossband repeater operations, and I have two links here for more information on crossband repeaters if you're interested in that particular thing. And then some of them also have wideband receive capabilities, including things like NOAA weather stations, aviation bands, which are AM, and even some of them have HF shortwave listening ability, but don't count on a lot of that because those radios, the HF capability in those handhelds and other radios like that are usually rather limited, and the antenna doesn't work unless you add another antenna. So don't think of that as your best shortwave listening radio out there.
Yeah, Anthony, let me mention one thing. Yes. You talked about wideband receive coverage. That can be good and bad. If you happen to be in a high RF environment, such as on a mountaintop somewhere where there's a lot of commercial activity, sometimes those wideband receive radios can suffer some significant desensing or interference. And some monoband radios, where they're only designed to cover one particular band, have tighter front ends, better filtering, and perhaps will be a little less affected in one of those high RF environments.
That is definitely true. And speaking of radios, I got to remember to turn my local repeater off. Okay, sometimes the solution is actually two radios, an inexpensive HT that you can put on your belt to use for close simplex contacts while hiking or for chatting at Hamfest, etc., and a mobile or base radio to address Marty's many points in the previous session and provide more reliable communications. If you thought you were getting into amateur radio and only going to buy one radio, I have a surprising thought for you. I don't know how many radios I have here in the house. I don't know how many radios I could actually touch within 5 seconds here. But that's why I sort of tell people when they're starting out, if you do really want to get an HT, consider an inexpensive or HT so that you're not blowing all your budget on it, and think more about the mobile and base radios, which we've talked about already. Here's an example of a base radio. This is one of the UHF VHF with HF. This is the ASU FT991A. And in addition to the radio, you will need a power supply and a fused power cord, and then an external antenna. Here's an example of the same type of setup, but in a mobile setting, using a VHF UHF FM only mobile transceiver. And again, you would need power and an antenna, whether it's a portable on your car or whether it's even an outside antenna similar to this. Now, in this case, this first radio has multi-mode capability. So in addition to FM, you would get those US single sideband CW capabilities in addition to the FM.
Yeah.
This
And by the way,
FM only.
you're showing the power supplies, Anthony. Let me mention that power supplies vary in their capability to deliver current, and they're not all created equal. Some are rated much higher than others in terms of output capacity. In our ACS and Aries group, we recommend, if you're going to have a mobile class radio, your power supply should be rated at least at 20 amps intermittent. Power supplies typically have an intermittent rating and a continuous rating. And the continuous rating is typically around 70% of the intermittent rating. And remember, when you're on FM, as long as you're holding the microphone down, your radio is putting out full power, whether you're talking or not. This is not true on sideband, but it is on FM. So you're putting full weight on that power supply, and it can't just be able to put that power out for a few seconds before it starts to get overheated. So make sure you get a supply that's big enough for your radio. Typically 20 amp, 30, 35 amp on up. And if you have extra capacity, that's great. You may be able to run an extra radio or two or some other station accessories.
Now, when I was putting together this slide, I didn't realize it, but I actually did not include a dual bander here. This is actually a quad band radio. The Yaesu FT890 and the TYT890 are both 2 meter 440, 6 and 10 meter FM only radios. Here's what you get in a typical handheld. You get a charger, a radio, an HT, usually a belt clip. Sometimes they'll throw in some sort of external microphone or headset, but not always. But this particular case, it does. So if you were to buy this, you would need some accessories. If you want to hook it up an external antenna, you might need an adapter to go from the SMA that's on here, like we talked about last week, to whatever your antenna feed line is. If you want to use this with batteries, you would need to buy a rechargeable battery cell container, or if you want to use it with DC power, you need a DC adapter for it. Here's some accessories. This is an example of a headset, a charger, a speaker microphone, and here's a DC adapter for one of these particular radios. I have a whole slideshow and a spreadsheet on buying amateur radio equipment. Again, when you see this little link in the slideshow, that means you can click on it. That'll take you out to that slideshow. And this particular one, buying an amateur radio, is available at this link, tiny.cc/buyar. And then when you go there, there's also this corresponding spreadsheet that goes with it. And the spreadsheet, if you're not used to using spreadsheets, has tabs across the bottom that are color coded. There's one red one that's the HF mobile, matrix. Then there's some older HF radios, but the one you're going to want to look at is the mobile VHF UHF matrix, and that shows different brands and different models. Now, most of these that I've included in this particular sheet are either currently available or recently discontinued, so that you might be able to find a used model. And you see which bands they cover. You see whether it has HF, whether it's a multi-mode radio or FM only if it's not a multi-mode, receive ranges, the power level. I have the highest power that it has available on VHF or UHF. It might vary based on the band, but this is the highest power on that particular radio. And then there's information whether it's a digital FM voice radio, whether it's DMR, D-Star, or the ASU Fusion. And then I have typical prices, new prices, and sometimes some of these radios are significantly discounted, so I've listed some of those prices also that the radio might be available for. And you see that I've covered a wide variety of brands on here. There's also another link with more information on HTs, different manufacturers with the link to each of the websites, different resellers that sell the different brands. Not all the brands are available from the same radio sites. Now there are other places you can buy radios new, but I did not include those. So buying a radio on Amazon means you might not get the same support as if you're buying it from one of these dedicated ham radio dealers. And surprisingly, you might not get as good a deal either. And then there's more information on rig jargon and rig reference. So it's a good thing for both HF and for VHF, UHF radios. In the slideshow, I talk about different ways of buying radios, how you can find them, if you're buying used, what to look for, and things like that. And I cover both HF and VHF radios in the slideshow. So back to you, Marty, for a little run-up on powering your radio.
Okay, very good. As I mentioned, an AC power supply is one that requires you to have either a commercial utility power, such as in the wall sockets in your house, or a backup generator, perhaps, that provides 120 volts AC. If you have an appropriately sized deep cycle battery, you'll be able to run your radio when the power is out. And when I say suitably sized, if you're running a handheld, something like a 12 amp hour battery could run it for a couple of days, depending on how much you're transmitting. If you've got a mobile radio, I know I've used 100 amp hour Bioenno batteries, where I have several radios going at the same time and can run them for, a couple of days without too much trouble. And if you are going to operate from your vehicle, you may be tying into your starting lighting ignition battery. And that has the advantage of always being charged when the engine is on. However, you have to be careful not to run the battery down to the point where you can't start the car. Ask me how I know that. So I carry jumper cables, and I've taken to using the big Bioenno batteries for most extended period operations, so I don't have to leave the car idling or worry about running the starting battery down. Go ahead. Power supply is something you should not skimp on. Get the biggest, beefiest one you can afford, especially if it's going to sit under a desk somewhere. I've had an Astron RS35A for probably 30 plus years. Never had to do anything to it. It comes on, it runs everything, and it's great. I also have the little these are linear supplies, which means they're heavy. They have a transformer, filter capacitor, and all that. However, there are switching supplies, and those are much lighter. They don't have a transformer. They use basically transistors to move the to vary the waveform and create the power. And they are much lighter. They're smaller. And typically, when I'm going on radio expeditions overseas, and we're having to do limit our weight that we're bringing along, that's what we use. And again, they are also available in some pretty good capacities, like 30, 35 amp and so on. I mentioned knowing the current required by your radio. Look at the manual and read it, and it'll tell you what current is drawn at when it's received, what current is drawn when it's on high power. And I will often measure that myself just so that I can confirm what it is at various settings. And that's why we say, even if your radio manuals say, well, it draws 11 amps on transmit, and you say, or 10 amps on transmit. Well, if you get a 10 amp power supply, that means it can deliver solid about 7 amps and maybe 10 on peaks. I've been to somebody's station where they in fact, I've seen this several times, where they transmit and the radio goes dead. And I look at the supply and I realize it's simply inadequately sized. They're trying to run a mobile radio on a 10 amp power supply and it can't hack it. So you got to get one that's big enough. And again, they're going to typically, unless you truly abuse them, they're going to last years and years and years. And you will have other radios, as Anthony said. Just because you get one doesn't mean you're going to stick with one. And being able to run more than one at the same time is really helpful. Most 100-watt radios, such as those that operate on HF, will require at least 20 to 25 amps. So I would go with a 30 to 35 amp supply. Next.
Now,
okay, we mentioned types of supplies. The linear one uses the transformer, the switching uses transistors. Anthony has a link here on which power supply is best, but very briefly, if you're going to leave this in one spot, such as under your operating desk at home, a linear supply is a good choice. The switching supplies can generate a lot of radio hash on certain bands. The good ones are pretty well shielded and filtered, but some of them are not. So I know back some years ago, ARRL in its QST magazine had a review of several switching supplies, and they talked about the noise generation that was or wasn't there. Again, that goes back a few years, but again, stick with the good brands, the known brands. And the other thing is the switching supplies tend to be fairly efficient. They're running like 75, 80% efficient, as opposed to the linear supplies, which are maybe 65 or 70% efficient. But if you've got plenty of AC power, that's usually not an issue. As far as the output, we're talking about 12 volts nominal, but that is a nominal rating. Your mobile radio, if you look at it, it's really designed to run like 13.6 to 13.8 volts, which is what you get from the alternator of an automobile when everything's running. So having having 12 volts, you don't want pure 12 volts. Ideally, you want the thing up in the 13s if you can. Some radios don't work very well when it starts to get down close to 12 volts. So we've talked about the current here requirement already. Let's go ahead and move on. Okay, typical power supplies. Here are some that we've used quite often: the Astron RS20 35, the SS30, which is the solid state version, Daiwa, Jetstream, Samlex, MFJ, and then Kenwood, Yaesu, ICOM, Malenko all have supplies that are basically made by others for them. They're private labeled, but they all are attested with those radios and they work pretty well. Next. A good deep cycle battery can deliver a lot of current in a very short period of time. And it's a good battery that's appropriately sized, can be enough to check into daily nets, but every few days you'll probably have to recharge it. But if you have to operate for a day or two without power, it's a good choice. And if it's going to sit at your house, the weight may not be such a big issue. You could use an AGM, for example, which costs a lot less than one of these lithium iron phosphate ones. The life POs are better if you're going to be moving around portable or in a vehicle, or you're going to move the thing from one building to another, whatever it may be. Those are much desirable because of their weight. Okay, the discharge curves I mentioned earlier. Typical discharge curve for any lead acid construction, whether it's flooded, AGM, gel, or whatever, it's almost linear. It starts at a fully charged of around 12.5, 13 volts, and it just keeps going down to about 10.5, at which point it's considered fully depleted. And if you try to discharge it beyond that, you may irreparably destroy the battery.
But one of the things that's going to happen is you're going to quite often run into a point way before you get to the 50-point mark where your radio is not going to like the voltage it's getting.
Yeah, you can see some of those. You may be halfway through the thing and it's only putting out 11 and a half or 12 volts. And again, unless you have a radio that has wide range of voltage operation, and I have some radios that do, even some HF radios that'll work down at that range, but a lot of them won't. And this is another way to check the manual and look and see what the acceptable range is. Okay, now I mentioned earlier the lithium iron phosphate batteries, the ones that are lighter but more expensive. Look at that discharge curve. It's almost flat, keeping you up above 12.8 volts for about 80% of the discharge curve. That's really nice when your radio is sensitive to voltage. And that means you get out of a single charge, you can run your radio for a lot longer and have it operate properly.
And by the way, you shouldn't be discharging to a 0% anyway. So this is about the point you're going to want to stop discharging this battery. So
yeah, it drops off quickly enough that your radio will know it. And the other nice thing about most of the lithium iron phosphate batteries is they have a battery management system, a circuit board in there, which will prevent, if you short circuit it, it will prevent, exploding or starting a fire. And it will also shut the battery off when it gets too low. So they have some safety stuff built in. Here are some typical batteries. Deca, the good maker of gel and AGM batteries. I found about them because they make locomotive batteries. And I figure they know what they're doing. It's American made. I have a Deca gel 100 amp hour. It's heavy. It's about 78 pounds. But that's before the lithium iron phosphates came out. That's what I moved around when I was at a demonstration at a fair or something like that. And then you have the lithium iron phosphates over there on the right. Then the cheapest choice is the flooded lead acid, like you'd find for most vehicles. I strongly recommend against those. For one thing, they can discharge hydrogen when they're charging, and you don't want hydrogen gas accumulating. You don't want your room becoming the Hindenburg. And also, if they tip over, you may have acid spills and so on. I know guys who have, acid holes in the bed of their truck from carrying lead acid batteries around that got bumped on a mountain road. Next. Okay, wire size. The basic rule is keep it as short as you can and use as big a wire as you can afford. Wire is basically a resistor, okay? All wire has some resistance, and the thinner the wire, the more the resistance. And if you remember your Ohm's law, you know that as resistance goes, as current drain goes up in a given resistance, your voltage is going to drop. The voltage drop will be a lot less with a nice big 10 gauge wire than it will with a little 16 gauge wire. And Anthony's got a handy table there. You'll find these tables various places. But again, bigger the better. For my mobile operation, I have a pair of number 6 cables. It's actually welding wire that comes from the starting lighting battery, and it goes through what's called a Class T fuse. And that's enough that I can run all sorts of radios on it. And it just goes from the from under the hood down through some tubing up to the under the passenger seat. And well, I'll tell you, I have no problem keeping the voltage up, even if I have multiple radios going. When you're charging a radio, make sure that you observe the manufacturer's specifications for charging. Some of them require a constant current followed by constant voltage. Others have very specific requirements. And as I mentioned, never charge a flooded electrolyte battery indoors or in some sort of enclosure. And I suggest avoiding them completely.
And you need to make sure that your battery charger, it matches the battery type you're using. So if you're using a lithium phosphate battery, you can't grab that battery charger that you had in the garage for your car. It won't work.
The Sears charger won't cut it.
It'll cut it. It'll destroy it for you.
Okay. sometimes people are tempted to say, well, I'm going to have some backup power, so I'll use an AC power supply and I'll just put the battery in parallel with it. So if the supply goes out, the battery will keep going. That's not a great idea, mainly because you don't know how that power supply is going to fail. Some of them have what they call a crowbar circuit, which in the event of a perceived short or overload will basically short the output. Well, if you have a big deep cycle battery connected to the output, it's going to short the battery. And now you got a real problem because, a shorted battery that can produce, hundreds and hundreds of amps on demand in a short situation can cause an explosion. So it's better to use some sort of device in between them. The common terminology is a power gate, but basically it's an isolator that allows the load to be drawn either from the AC supply or from the battery, but not both at the same time. You see a couple of examples here. West Mountain Radio makes a number of them. And there are several other good ones. I think it's KB0IK has a little low loss power gate, little blue box that's fairly inexpensive, and it's good to, I think, around 25 amps. So that's another nice one. Some of them have the ability to add a solar panel as well and other charging source. Some of them, if you're running it off the power supply, there'll be a trickle charge that you can set to keep the battery charged up if it needs it. The lithium iron phosphate ones don't really need a trickle charge. Once they're charged up, their internal drain is almost zero. You could leave it on the shelf for months and you go and grab it and it will be at full power.
And if you don't want to go through this, at least use a switch so that there's only one power source at a time. You never want to have both of them connected at the same time to your equipment.
Yeah, and if you use a switch, it better be a beefy one.
Yes.
Because all the current that you're drawing is going to go through it. There are some nice ones made for the marine environment, such as Blue Sea Systems and some of those. Look at the marine supply stores for DC switches, and you'll see what I'm talking about. Power distribution devices. There's many of them out there. Some of them have fuses on each leg. They have meters and so on. I don't go that fancy. I basically use things that are bus bar wired so that we have as little loss as possible. And I use stuff called Ready to Connect. And I know I knew the fellow who invented that and sold it. Eventually, I think it got taken over by another company. I think possibly PowerWorks. But I like them simple. I don't need a lot of fuses and meters. The radios have fuses in them. My supply, my big battery has a fuse right at the output, so I'm good. These things, Anderson power poles. If you've operated with other hams in a field environment, you've probably seen these. And if you're not familiar with them, I would advise you become familiar with them. It's not the only way to go, but it's kind of become a standard, which is, and standards are good. Standards allow you to interconnect and swap your radio with somebody else's supply, their radio with your supply, your radio among multiple different supplies. You could, instead of having to take off lugs in the back of a power supply and then figure out how to connect it to a battery, you could just unplug from a little pigtail on the battery, plug it into a pigtail on the power supply, and you're good. These are crimp connectors. You want to use the proper crimper. And there's an illustration there of what a properly crimped contact looks like. This is the 45 amp series of power poles. And there are actually 3 different sizes of contacts. Those are the little silver things there that you can put on them, depending on the size of the wire. Each one is designed for a different range of wire sizes, but they all fit into the same housing. One of the nice things about this is that the wiring for the housing and the wiring is the same, whether it's a supply end or it's a load end, like a radio. So you don't need male and female connectors of this kind and that. if you're wiring up a power supply or you're wiring up a radio, you put these on in the appropriate configuration with the hood on top, red on the right, black on the left. And when you turn them upside down to mate them, everything will be perfect. Anthony's got some links there to videos showing how to put these things on. And if you don't have the proper crimper, there are some available. For the big wire, you definitely want the Anderson crimper. I found the aftermarket ones are not very good, but for the 30 and 15 amp contacts, the aftermarket ones are fine.
And I've been using these since the 1980s when people thought they were really weird, and they were very expensive. So they're very reasonably priced now.
Yeah.
We have these on our railroad trains. I volunteer on the scenic railroad. We have the 480 volt versions that I'm not sure how many amps they handle, but they're this big.
Yeah. And by the way, that there are several larger sizes with exactly the same construction. I have a 75 amp version that I use on that big pair of wires coming out from under my hood on the car, and from there I can distribute it to several 45 amp outlets, power pole outlets. So the 75 amps are good for maybe a big battery or a big power supply. We're going to have several things plugged into it. All right. So if you want to install something in a vehicle, this is not the way to do it. We have a separate presentation that we've done on RATPAC, and you can go into the archives and see it. It was done back in October, and it talks about all the safety issues and effectiveness issues in terms of cabling, in terms of mounting, in terms of power, in terms of coax selection, antennas, and so on. So if you're really interested in going mobile, I suggest you take a look at that. And there's another website, K0 Bravo Golf, K0BG.com. Anthony or Alan Applegate has a phenomenal, very, very detailed set of articles on mobile operations, including HF mobile, which mine does not cover.
Yes, and if you've never been to a site before, it's like the mobile radio site. It's K0BG.com. And he has a lot of great information on installation, antennas, etc. Okay, thank you, Marty. Let's talk a little bit about the other type of interfacing you might do besides power. Many of the newer VHF, UHF radios have computer interfacing capabilities, but the use of the computer interfaces vary considerably differently. Most HF radios are interfaced for the purpose of radio control, rig control. But for VHF, UHF radios, some of them allow you to interface for programming memories only. Some let you do radio configuration. Some allow you to do cloning, and the cloning cables typically don't even need a computer. You create a cable and you hold down some buttons on one of the HTs and have the other HT connect on the other side, and it'll clone it, or same thing on the mobile radio. So if you're doing multiple radios and you want all the same memories, you can use cloning software that's cloning ability that's built into the radio, but you do need the proper cable. There's also rig control, just like on HF radios, for reading rig information, changing radio frequency mode, etc. This is mainly on the multi-mode radios and the base radios, not so much on the mobile FM only radios. And then also, if you want to do digital sound card modes, you're going to need a radio capable of single sideband, but then you're also going to need some sort of sound card, whether it's built into the radio or use a separate device like a Tigertronic Sound Blaster. Thank you. I couldn't remember that for a second. One thing I forgot to put on the list is you may need to be able to connect to your radio to your computer for upgrading to the newest firmware. So a lot of the new radios have firmware upgrades, and I forgot to add that. So that might be something you might need to do also. There's a couple ways to go about doing this. Whether you're going to be doing memory programming, cloning, or other radios, you're going to need some software. Sometimes the software comes with the particular model of radio. Some manufacturers provide it, some do not. And if they don't, then you need to look to a third party. RT Systems is a commercial product that has a lot of different software available for different radios, and they also have the hardware interfaces, in other words, the cables for all these different radios. If you don't want to go that route, there's a free product called Chirp. Now, the downside to Chirp is it doesn't provide the cables, so you're going to need to get the cables somewhere or make them on your own. And it's a little bit counterintuitive. Let's describe it that way. It's a little funky, and once you get used to it, it works very well. And I do use Chirp all the time, so I'm not complaining about it. But it is not the most obvious thing when you use it. So it's good to find Chirp and another ham who knows how to use it at the same time. But it's open source. For rig control, typically base radios, you're going to be doing things like logging and contesting, digital sound card modes. And most of these newer radios typically use a US A and B cable, similar to a printer cable. Some of the older radios, though, do use RS-32, and some even have proprietary interfaces if you go back a couple years. But if you're getting something that's less than 10 years old, it's probably going to have a USB cable interface. If you're using a USB to serial adapter cable, make sure you choose a quality cable. You can get so many headaches by going cheap here. I recommend ones that have an FTDI chip in them, not a prolific chip in it. And I've also found that if the cable's blue, it almost never works. The cheap blue cables are just garbage. So again, find a quality cable with an FDI chip in it, and you should have good serial to USB communication. If you're interested in this, I have 2 slideshows, one on logging and contesting software that covers the interfacing process in depth. And then if you're interested in getting set up on the digital modes of FT8 and FT4, I have a whole section on digital sound card modes. These are both presentations you can go to. All my presentations are available at tiny.cc/K8ZT-P. So where are you going to put this radio? And hams over the years have a term of endearment for their radio locations called a shack. Sometimes the shack was a little room out back, and it was especially useful in the days when you had wet batteries that might be full of acid, and you might have smells such as ozone being produced by your spark coils, etc. So shacks could be in the house, but sometimes they were outside, garages, sheds, basements, spare rooms, etc. For your first VHF UHF station, it might be very simple, but there are some things to consider: noise and privacy, both yours and those around you. Power that's sufficient. If you're going to be running amplifiers, especially with some of the HF equipment, you might need 220 or higher amperage service. A desk or countertop for the equipment. The ability to keep equipment safely isolated from infants, children, or pets. Everyone always shows the cute pictures of cats crawling across their equipment, but they don't show you the pictures when the cat knocks an expensive piece of equipment over onto the floor.
They never do that, do they?
Yes. Well, maybe dogs do, but none of my pets have ever done that. If you don't have a place where to permanently set up a shack, you might want to consider a go box that you could use both in the field, but you could also have your go box at home. My first shack on HF was a go box with my Argonaut 515 in it that I could take out and put it on the shelf. When I wasn't using it, I put it in the closet because we didn't have much room. Here's an example of a roll top desk as a way of isolating your equipment. I have some presentations on go boxes that you're welcome to go to.
And also there is a RATPAC presentation by some young ladies back in the Southeast who have become, they've started a business doing custom go boxes, and they've gotten quite good at it. And you can go back to our archives and see that.
And then some other considerations: a comfortable chair allows you to operate much longer. Now, you might want some workspace area. My wife's agreement was I couldn't move the shack out of the basement unless I left the workshop area in the basement. So I actually have 2 areas: my workshop area and my operating space, which is up in the main part of the house. You're going to want some other things in your shack. So room for your awards you're going to get. You're going to need place for those certificates when you win contests, etc. So what we're going to talk about next is getting cables into the shack, and I have some examples here, not all of which are good ideas. Some of them work out well. I've used everything from a dryer vent to feed things into the house, to PVC pipe, to nice little boxes mounted on the wall that close and have a great place for doing things. Panels that fit in window openings, etc. I have a video here on bulkhead panels with connectors, similar to this bulkhead panel. What we need to do though is we need to also maintain safety. So I'm going to turn this back over to Marty.
Okay, and we want to talk just a minute about the National Electrical Code. Wherever you live, you have some building codes, and usually they make reference to the National Electrical Code. And that code requires that each conductor of a lead-in from an outside antenna has to have an antenna discharge unit, which is basically a lightning arrestor. Go ahead. Here are some examples of commercially made lightning arresters. Their ratings may vary by how much power they can handle, and particularly what their useful frequency range is. You don't want one that's not the appropriate range, because it'll suck all the signal out, and you won't have the coverage you needed. So here's what that requires. The ADU has to be located as near as practical to the entrance of the conductors, and then grounded in accordance with other specifications they have there. Basically, if you have a panel here with your antenna discharge unit, your lightning arresters, and then that comes in, and then you have to have a ground rod and 6 or 8 gauge wire going to wherever the AC comes into the house, where there's also a ground.
Here's an example of one.
You're kind of looking top down at a ground rod.
Here's some panels. Now we're going to pass this off to Ward Silver, N0AX, who has a great book and video on that. And a couple things you need to remember though: the RF ground is not the same as the electrical ground. And distance between equipment and ground is important. I have an alternative view here from Steve Katz, which I think is rather interesting. We're trying to get him lined up to maybe do a RATPAC presentation in the future, and there's a link that you can go to his material. So that ends tonight's part 2 of VHF UHF introduction. We'll go ahead and take questions. First of all, we'll cover the questions in the chat, and then if you have a question that you'd like to ask, we'll be happy to do that. So one question I saw here was about a dribble wire, and I think what they're referring to is something we talked about in last week's session that I referred to as a tiger tail. Is that what you do? Is that what the dribble wire is, Tom? It's a little 19-inch wire you attach to your 2-meter antenna ground?
Yeah, the one that just fits under the antenna with a ring terminal.
So if you go back to the video from last week, we talked about that. Tamara asked, she says that's my power supply on the right there. So let's see, for receiving. What do you think about so-called boost regulators? Marty, you want to talk a little bit about boost regulators?
Yeah, I have not used them myself. I know a few people who have. A boost regulator is basically something designed to keep the voltage going to your radio or other load above some certain threshold, say 12.5 volts, when the power, say the battery, starts to drop down. They are, obviously there's some current limits to that. And I really never use them myself. If you had a radio that requires particularly high, say it really doesn't operate well until it's over 14 volts, and your supply is just up to 13.8, I could see using something like that. But the idea of using that in lieu of a battery of adequate size is questionable, because all you're going to do is drain the battery faster. That's just my opinion. Again, I've not used one. I try to pick radios that operate over the voltage range that I have available.
Yeah, and they're not cheap. A good quality boost regulator is not cheap, and there is, it is eating up battery current while it's keeping the voltage at the 1 point. So sometimes you're better off just, resizing your voltage source so you don't have to use that. So if you have any questions, if you want to raise your hand and let us know, we'll be happy to acknowledge any questions out there. Okay, I'm not seeing any questions. Please feel free to contact us via our information. Just a couple things real quick here. We have our beginning information. The RATPAC list that we were referring to earlier is at tiny.cc ratpac.list. I'll put that in the chat here. And when you go there, you'll find over 209 after tonight recording, and you could go through those. You also see the upcoming RATPAC sessions listed there. And then the second thing is I have a whole list of presentations I've done over the last 3 years here, or 2.5 years. And if you can get to any of these with a slideshow, some of them have recorded videos. And if you'd like a presentation for your local club, just drop me an email. I'd be happy to do a presentation for any club. I'm trying to work to present all states, to present in all states award. So I've got about 35 of them, and I got 4 DXCC entities also. So
Very good. Thanks, Anthony. And Tom